Okay, we are praying. Heavenly Father, we thank you for today, Lord. We bless you for your good hand in our lives and for your good hand in Landmark, Lord. We thank you for the matriculation ceremony today of class 34 and the graduation ceremony today of class 32. It has pleased you, Lord, to favor every one of us, and we have come to say thank you. Be exalted, be magnified. In Jesus' name, amen and amen. Okay, so can you hear me, everybody? Can you confirm if you can hear me? Good job.
We can hear you loud and clear.
Okay. Okay, so we'll start by talking about DevOps. What is DevOps all about? And why is it that companies around the world today are craving for individuals with DevOps skills? Why are DevOps engineers being chased? Why is there a scramble for DevOps engineer or DevOps engineers? So first of all, look at that end-to-end demo when it comes to what DevOps is all about. So that said, I'm going to share my screen with you guys so that you can get to have a good understanding when it comes to the DevOps end-to-end process. Today, we are starting with class 34, and it's good that you guys have an understanding of how the end-to-end program, or DevOps is all about. So I'm going to be sharing my screen at this time. Make sure you can see my screen, everybody. If you can, just indicate, and necessary adjustments will be done. Can you see a diagram?
Yes, Prof.
Okay, good job. Okay, so we want to look at DevOps engineering, and we'll be looking at DevOps engineering strictly from how a lot of things have been accomplished in the past when it comes to project management. Okay, so we'll be looking at what we call we're looking at software. Let me make sure I get it correctly. Look at the software development life cycle. Software development life cycle. Software development life cycle. We look at how software has been developed over time. And today, okay, we have a company, and that company is Landmark. This Landmark Tech. This is Landmark Tech. Landmark Tech is a software development company. So Landmark Tech specializes in software development, okay, among others. Now, apart of Landmark Tech, we have a client, we have a customer. And this customer, let's assume is Facebook. So Facebook is a customer. So we classify Facebook as the client. So Facebook is the client or one of the clients of Landmark Tech. So Landmark Tech have, many clients. Among the clients is Facebook. Now, so Facebook confront Landmark and request for certain tasks to be accomplished. And that task is to manage their software development projects. You see that? So this is a very key aspect. So Landmark Tech will be developing softwares for Facebook. Now, in this, development of software for Facebook, there are a few things to take specific note of. And those are the things we are going to be looking at carefully. Okay, now, so in developing this software for Facebook, there are a few options that, or a few methods that can be implemented. So we have software development lifecycle, okay, approaches. What are the different approaches that, or methodology? Let me put approaches. Now, we have different approach that can be used to achieve this process. We have traditionally the waterfall approach, the Agile, and Devops. So we're looking at these three approaches and why they're very important and why you should know them. Now, again, we have Facebook as client, and we have Landmark Tech, okay, as the company developing software for Facebook. So we want to talk about the waterfall approach or waterfall methodology. So we have what we classify as waterfall methodology. How does this methodology works? How is it implemented? Now, again, with this methodology, we have Landmark Tech. Landmark Tech is the software development company confronted by Facebook. Who is Facebook? Facebook is the client. So we have here Facebook as client. So now, if this particular approach is being implemented, let's see how it's going to work using the waterfall approach. Now, with this waterfall approach, the very first thing that is going to happen, okay, is that there's going to be what we call requirements. So requirements are going to be gathered. That's the first thing. So we are going to come here and ensure that requirements are gathered as far as this particular approach is concerned. So we are going to be gathering requirement for this project. Okay, so there's going to be requirement gathering. Let's see how it goes. So now the idea is, once we gather requirement, means we understand what Facebook wants, we are going to come up with a design. Okay, so let's see how this is going to work. So we have here requirement gathering. Let's see what happens when it comes to requirement and what are those involved. So now we have, you know, let me make sure I have something like this. Let me use circles for better illustration. Now, requirements are being gathered. Who are those involved in gathering this requirement? Who are those involved? Now, when it comes to requirement gathering, we are going to have architect. Okay, the architect, and team leads. These are the folks that will have a sit-down meeting with Facebook. So architect from Landmark Tech will have a sit-down meeting with Facebook to understand what exactly they want the organization to do. So once requirements are gathered, okay, the next thing that is going to follow, now we have understood, it's going to be to designing stage. Design. Now, what is involved in the design stage? What is involved here? We have requirement gathering. What is involved? Who are those involved in this stage now? In this design stage, we are going to try to understand which kind of computers are we going to be able to run these applications on. So, okay, and what is required? So we are going to have what we call high-level documentation and systems requirement. Which kind of system do we need? And what are the documents involved? Okay, in applying, in developing the software for Facebook. Because the entire Facebook is a chain of software running in the background. Everything that gets to do with Facebook gets to do with softwares that are deployed and they are running. That's what Facebook is all about. So somebody have written some software. Okay, so now let's look at something. Once we have a design, we understand what is needed. Once we have understood, it means this design is like having a prototype. It takes us to implementation stage. Now, what is involved and who are those involved in this implementation stage? In the implementation stage, okay, we start developing the software for the client, which in this case is Facebook. And those that will do this development will be developers. So in our team, we have developers. So developers are going to be involved in writing, in designing the application, okay, in implementing, that is, in writing the code. This is development. Now, once they are done developing this application, the next thing that is going to happen after development, okay, is testing. So this application is going to go through testing. Who are those involved in the testing phase? Who are those involved when it comes to testing? In the testing phase, we are going to have our quality assurance team, testers or QA team, folks that are in charge of, okay, you know, this application has to be tested. The software has been developed. It has to be tested. So Landmark Tech is managing this entire process for Facebook. Now, look at something, please. Okay, now, once we have the application tested, what happens next is that it needs to be taken to the market. The process of taking this application to the market is what we call deployment. So it has to be deployed. It has to be taken to the market. Deployment is involved here. So this stage gets with what we call deployment. We are deploying the application. As you can see here, we are deploying the application in this stage. You see that? So this is what the end-to-end process is concerned. If you are going to use what we call the waterfall methodology. Now, it has been tested. Okay, we have different tasks is involved in each of these stages. Now, we have developers, we have QA team. Let me make sure we have here team leads. Okay, developers, QA. Now, who are those involved when it comes to development? When it comes to deployment? Deployment are some what we call middleware admin. Middleware admins will manage this deployment. Now, after this application is deployed, it means if you go to facebook.com, okay, facebook.com, you should be able to access the application, facebook.com. It is deployed, it's running. Can you see that? You can access the application. This is Facebook. But again, you know, once the application is running, there could be a problem and it goes down. How do we know? How do we fix that problem? We have a stage called support. So there is a phase that is involved in, okay, supporting this application, ensuring that it is running at all times. So this will get to what we call the maintenance stage. Maintenance. Okay, so we have here maintenance phase of this end-to-end process. It has to be maintained. So we have the maintenance phase. So this is the end-to-end traditional approach that we can use when we get to do with the waterfall methodology. But now, the problem with this, what is the problem of implementing waterfall? What could be a problem if you are going to implement waterfall? Now, if you implement waterfall approach, the problem here is that, to start with, resource utilization. Resource, the usage of resources, resource usage is poor. How do we use our resources here? Resource utilization. Okay? Resource utilization is poor. For example, now look at something, please. Now, if you look at when requirements are being gathered by the architect and team lead, the rest of the team, they are idle. When developers are writing code, they are doing implementation. What happens to the rest of the team? The rest of the team, the QA guys are idle. The deployment guys are idle. The support team are idle. So the way resources are managed here is very poor. So we have poor resource utilization. The next one is poor, timing. Poor timing. Now, if you look at this approach, when you implement this approach, now it can take up to 4 months. This could take up to 4 months, to be implemented. Now, you take 4 months, and what happened? After you have done everything and deployed the application to the market, there is a problem. It means that you have to repeat the entire process. So the timing is poor. Resource utilization is poor. So, but this is the waterfall approach. This is what traditional project managers have implemented over the years. Now, because of these lapses, you realize that now, there have been a few changes. So most organizations has moved from this approach, this waterfall approach, to what we call the agile approach to project management. So what else can we implement? We can implement what we call the agile approach. So we can use the agile methodology. Now, how does the agile methodology work? The agile approach. Now, when it comes to this agile approach, now we still have our client. Landmark is a software company. Facebook is the client. Same thing. You see that? Now, let's see how we can implement this agile approach. With this agile approach, what happens is that now, the client, the software company will have a good understanding with the client as regard what do they want. What do you want us to develop for you? Once that understanding is obtained, what follows is that now, under this approach, under the agile approach, we have different frameworks. We have framework like the Scrum framework. You see that? For example, we have the Scrum framework. We have the Scrum framework. We also have the Kanban framework. Kanban framework. We have a good number of frameworks that you can implement. But now, let's talk about the Scrum framework, how it works in this approach. Now, with the Scrum framework, which is common for Scrum Master. Now, with the Scrum framework, there are a few properties that is common with this approach as far as the Scrum framework is concerned. Now, with this Scrum framework, the entire development of the software is going to be breaking down into units. And those units is going to be processed, using what we call iterations. So we are going to use iterations or sprints, or sprints to, develop and serve clients. This is what we are going to do. So now iterations is going to be used to develop and to serve our client, which in this case is Facebook. And a sprint represents a kind of, let me come back here. A sprint or iteration represent a production period. It's like a development window or period. And generally, it lasts for about 10 working days. So this development period generally lasts for 10 working days. Okay, so now let's assume that we have our team. Okay, now in this team, in this framework, we have a team. Who are the team members? In this team, we have 4 developers. 4 developers are part of the team. We have 1 Scrum Master. We have 2 guys that are QA guys. Okay, now, these are members of the team. And probably, you know, we have some sysadmin guys as well. Sysadmin. So we have some sysadmin. So these are members of the team. Let's see how this team is very important in this particular approach. So we have here members of our team. These are team members, 4 developers. Now, these are the members of our team. How is this very important in this approach? Now, we have sprint 1, okay, which is going to last for 10 working days. That's sprint 1. In this sprint 1, we decide that we are going to be working on 8 features. 8 features for this client, because you are developing a software for your customer who is Facebook. Now, 8 features. So in sprint 1, okay, we have this number of features being developed. How about in sprint 2? So in sprint 1, we have 8 features. Now, in sprint 2, let's observe something. So we have here sprint 2, which is lasting for another 10 working days. So in sprint 2, now, instead of having 10 developers, we have just 3 developers are available for this sprint. So we sit down in a meeting and decide that we are going to be working on 6 features. So this is how this agile approach works. But I'm coming. Now look at something, please. What do you observe? You realize that when it comes to the agile approach, okay, what are some of the problems with this agile approach? Okay, now, if you look at, this is taking 10 working days. Timing equally could be a problem. But in this case, we are using just 10 working days. We are going to know why 10 working days could be a problem, because with Devops, we can use hours to achieve the same tasks. So timing could be a problem. But again, one other problem is team velocity. Team velocity here is high because now, if you look at something here, you realize that in sprint 1, we were able to deliver 8 features because we had 4 developers committed. What happened in sprint 2? 1 developer is absent for whatever reason, and we can only deploy 6 features. That's a serious issue. So how can this be fixed? Or how have this been resolved over time? How have this been resolved over time is a key aspect to look at it carefully. Let's see how we have been able to resolve this over time. Now, but again, before I even talk about how that can be resolved, there is one very important aspect I want us to take specific note of. And what is that aspect? Okay, now Now, look at something here, please. Team velocity here is very high because if members of the team are not there, it's going to be a serious problem. But again, there is one other thing I want you to take note of here. Now, timing is still poor comparing to what we are going to be seeing with DevOps. Timing here is still a problem. Team velocity is high because if a member of the team is not available, our total number of deliverables is going to be affected. But look at something. So about this approach, we have seen teams. What else have we seen? We have seen sprint. Okay. What else have we seen? We have seen teams. We have seen sprint. And one thing that's very important are meetings. So this approach, okay, there are a few things about meetings which we need to take specific, okay, knowledge of. Now, when it comes to the agile approach, like Scrum, for example, now we have meetings like daily stand-up meeting. Daily stand-up meeting. Okay, what else do we have? Now, we have sprint planning meeting. Planning meeting. What else do we have? We have retrospect. Retrospect meeting. Now, so these are the meetings to take note of. What is a daily stand-up meeting? So as far as this approach is concerned, one of the importance of, okay, the agile approach is the integration of meetings. Because what happened is that now, in this approach, meeting, okay, for example, for each day, there is a daily stand-up meeting where, now this meeting lasts generally for 15 minutes. It's a 15 minutes meeting. 15 minutes. Now, what is discussed in this meeting? In this meeting, members of the team will come and try to explain what they did the day before. Let's assume this meeting was holding on a Friday. Now, the members will say, on Thursday, I was tasked to do ABC. I was able to do ABC, or I could not do B because of this. Okay, so daily, there is a stand-up meetings. Therefore, this approach can continuously, ensure that, processes are improved upon. But again, before a sprint starts, there is a sprint planning meeting. For example, sprint 1. Members of the team will come together and they will discuss, what are we going to be doing in this sprint? Who will be doing what? And all of this is going to be agreed upon. You see that? Now, at the end of the sprint, there is what we call a retrospect meeting. What is the use of this retrospect meeting? The retrospect meeting, okay, retrospect meeting. Now, members of the team will sit down. What were we supposed to do in sprint 1? What did we do in sprint 1? What lessons did we learn? Okay, what is it that we could have done better? That is a sprint planning, okay, retrospect meeting. But again, the problem with this approach gets to do with the fact that team velocity is high and there is some problem with the timing. So please take note, it's very important. And this takes us to, okay, a very important, as a matter of fact, the retrospect meeting is like a review meeting. It's a review meeting. Now, but this takes us to something which is very important that we call DevOps automation. Let's look at how DevOps comes into play and automate this entire process. So we have DevOps automation. Can we automate with DevOps? The answer is yes. So when it comes with DevOps, this is what happens. With the DevOps approach, now, this is Landmark Tech serving Paper as client. Paper is the client of Landmark Tech. This is Landmark Tech. Sorry, in this case, Facebook, not Paper. I know we've used Paper examples in the past, but today we are looking at Facebook is the client. Now, this is Landmark Tech, DevOps automation. Now, Landmark Tech has a team of developers. What is their job? Now, these developers are part of the Landmark Tech team. What are they doing? they are busy developing, they are writing code. And when they write this code, they commit the code to a tool which we call GitHub. So there is a tool that is able to manage this code. It's what we call an SCM, source code management. So we have source code management, SCM. Now, the SCM tool that is common, okay, we have stuff like GitHub. We have GitHub for SCM. We have GitHub. We have GitLab. Okay, we have Bitbucket. Now, these are all software tools. SCM, source code management. So these are source code management tools. So developers are writing code. What else are they writing? Now, they are writing what we call the source code. They are writing the source code. For example, they can be writing a code called app.java. This is the source code. Okay, now, developers are writing source code. They are also writing unit test cases. For example, they are writing app test, okay, .java. Now, this is unit test cases. Developers are writing unit test cases. What else are they writing? Now, developers are equally writing what we call the build script. Okay, now they are writing build script. Okay, like the project file. Developers are writing all of this. So when they write it, they commit it to GitHub. And developers are using a tool that permits them to collaborate. And that tool that developers are using, okay, SCM, we call that tool Git. Git is used for versioning. Now observe something. These are developers writing and committing code. So when they write this code, they commit it. Now, and when they commit the code, so developers can, they collaborate with each other. In that collaboration, they are not only writing code, okay, they can equally get some code from GitHub and they work on it. So you see how the arrow is. So either the arrow is being pushed or it's being pulled and repushed. Why? Because now developers are using what we call a distributed version control system. Distributed version control system. And that distributed version control system is Git. Let me come back here. So they are using a distributed version control system, which is called Git, okay, for their project. Distributed version control system. Because again, when you work for Facebook, right? You work for Facebook. Facebook have hired you. Now, they may have version 1, different versions of the application. There is version 1. There is version 2. Okay. Now, version 2, we have version 3. Now, these are different versions of the application for this client. For you to better manage it, we need a version control system, which in this case, we are using what we are going to be seeing in the course called Git. This is used for that purpose. And we have a source code management system, which could be GitHub, GitLab, or Bitbucket. Now, when they write this code, they're equally writing what we call test cases. So the code has been written. Once the code is written, the next thing is that now, look at something here, please. Once this code is written, okay, now, we have a tool that is used to automate the entire process after the code is written. That tool, as you are going to be seeing in course of the program, that tool is a software called Jenkins. Jenkins is a very powerful software. So we have an automation software. Look at something, please. This automation software is called Jenkins. Now, let's see what Jenkins is going to help us to accomplish. Now, when you have Jenkins like this, when developers write the code, okay, now the first thing is that, so the first step that happens is that developers will write the code and they will push the code. they push or they do what we call commits. Now, developers will push this code to the source code management. Okay, they will push the code to the source code management. Now, when they push this code, the guy in charge of automation, his name is called Jenkins. Now, Jenkins will do what? Jenkins, in part 2, Jenkins will pull this code. So the code has been pushed to GitHub. Jenkins is pulling the code. It pulls the code. Now, once it pulls, because Jenkins is the guy that is going to be achieving what we call automation. And which kind of automation? CI/CD. CI/CD, continuous integration, continuous delivery. Now, when Jenkins gets this code from GitHub, what Jenkins does is that, please watch the screen carefully now. Jenkins communicates with one other tool to do what we, to compile, to test. So it does compilation. Now look at something, please. This tool is going to compile the code because, again, now, this code that has been developed is intended to be deployed to some application servers. So Jenkins have pulled this code. Now, Jenkins could take this code to the customer. Here is the customer. Okay, the customer is Facebook, FB. So we have a Facebook app server, Facebook application server. Okay, now we have Facebook app server. Now, the customer, so this is a Facebook app server. Now, look at something here, please. Facebook app server. Now, this code, so this guy, Jenkins, is able to deploy directly to the customer. Before this happens, there is something very important. This raw code cannot be taken to the customer. The raw code should not be taken to the customer in that format. So what happened is that it goes through what we call a compilation process. It goes through what we call, stage 3. In stage 3, this is what we're going to do in stage 3. We are going to test, and build. So we test and build. So stage 3, we have to do a build. And for you to do a build, now, for a build to be done, there are different tools. For example, we are managing Java projects in our environment. So the tool there include Maven. You can use Maven, you can use and other build tools. Now, observe something. Now, this code, because the code that is found in source code management, this code here, is something that is source code. Source code. And, here's our source code written in Java. So the source code is in our source code management. Now, this source code is raw. This is raw code. It cannot be understood by this application server. So it goes through this build, this build software, this build server that is going to convert this code into packages that the application server can understand. And it will equally run some unit testing on it. Those packages can be something like this app.war, or we can have, war packages or year packages or jar packages. These packages are created. Now, once these packages are created, this is, let me make sure you are getting it correctly. Now, we have created packages. Now, what happened next is that we are ready to deploy this application. If we are ready to deploy the application, we can't just deploy. We have to, first of all, qualify the code. And how do we qualify the code? We qualify the code by, using another tool. And what is that tool going to accomplish? Let's see what that tool does. We have a tool called, that tool that is going to be doing code quality analysis. Code quality analysis. Now, which tool is it that does code quality analysis? So we want to achieve code quality. Step 4. 4. We want to do code quality. Now, step 4, we are going to be doing code quality. And how can this be accomplished? There are different tools that are involved here. For you to accomplish this, we can use tools like SonarQube. Okay, we can use SonarQube. So this will perform code quality analysis to qualify the code, to give a report that the code that has been worked on, okay, meet all the specifications. So please take note, it's very important. Now, the next thing to take note of is that once this code is qualified, it means we can now deploy it to the app server. But before it is deployed to the app server, we have to ensure that, you know, nothing failed, because in course, you know, you may want to deploy and that deployment process fails. So how do we avoid it from failing? We create a backup using what we call an artifactory backup, because we have created, okay, an artifactory. Now, these are artifacts. War, ear, and jar are artifacts. This artifactory can be created in Nexus or JFrog. So we can create it in either Nexus or JFrog. Now, these are artifactory, which means that once these artifactories are created, we are going to have our WAR file, okay, our ER files, and our jar files, both in this build saver. Okay, here is the build saver. Okay, and here is the artifactory. So it is found in our artifactory saver. Okay, and it's also found in our build saver. Therefore, now if you are trying to deploy to the customer and something goes wrong in your build saver, you have it back up in your artifactory saver. Take note, it's important. Therefore, this process of, okay, you know, uploading artifacts to Artifactory, okay, will represent stage 5, which is upload. Okay, upload. Here we are uploading artifacts to the Artifactory. Once it is uploaded, the next thing is to do is to deploy the application. So we have this Facebook deployment saver, Facebook, okay, app saver, or deployment app saver. So here is our Facebook deployment app application saver. So now, once it has been deployed, if something goes wrong with this guy, how are we going to know? And how can we manage it? Still, from Jenkins, okay, from Jenkins, now we are creating what we call, let me come back here, a tool. From Jenkins, we are creating a tool, you know, to manage, as a matter of fact, here is the app saver from Jenkins. And again, before I even go to talking about how this can be managed now, in a production environment, we will not deploy to only one app saver. So we are going to deploy to multiple app savers. So we are going to bring up another tool, which we are going to be seeing in the course of the program. That tool is called Ansible. Okay, we use Ansible. Now, with the help of this Ansible tool, it brings automation again in the system. Now, Ansible can help us to deploy to multiple app saver for our client. So we have here App Saver 1, App Saver 2, and App Saver 3. This is for high availability. Therefore, the Facebook customers who are trying to access the Facebook application, if something is wrong with App Saver 1, these customers are able to access the application from other app savers. Okay, so we have here App Saver 1. So with the help of Ansible, okay, we can be able to deploy even to 1,000 application server at once with the help of Ansible. And that is what, okay, that is what automation is all about. So we bring Ansible to take automation to the next level. Can you see that? This is the use of Ansible. So with the help of Ansible, this process is automated. If there is a problem with App Saver 1, then Facebook customers are going to be directed to App Saver 2. If there is a problem with App Saver 2, they'll be directed to App Saver 3. But now, what happened? If there is a problem with this application saver, how do we know if something goes wrong with the app saver? If something goes wrong with the application, okay, now we are going to be introducing another tool Okay, and what is the use of that tool? That tool is going to be monitoring the system. The use of this tool is to monitor. So we have a tool that is expected to do monitoring. You see that, so this tool does monitoring. So what is this tool going to be doing? Monitoring. Monitoring. So this is what the tool does. It does monitoring. It monitors the system. And tools that are very good that we can use, or which we are going to see in this course, will include stuff like New Relic, App Dynamics, okay, Nagios, okay, we'll look at Prometheus. Now, these are all tools that can be used. Can you see that? So if something is going wrong, we have some tools that are monitoring the application servers. They are monitoring the servers. So if something goes wrong, for example, okay, with any of the app server, this tool is going to be notified immediately. You see that? It's going to be notified. And what does it do? Now, once it is notified, it will contact our support team. Support team will be contacted. Something is wrong. And what do we expect support team to do? Now, support team, once they are contacted, they will raise a ticket. So they will use a different tool for ticketing. And which are the common tool for ticketing? So we have here, this is ticketing. Okay, so ticketing and bug tracking. Bug tracking. Now, if something is going wrong, we can use a different tool for ticketing and bug tracking, stuff like Jira. We can use Jira. We can use ServiceNow. There is Jira and there is ServiceNow. And ticket is going to be raised and members of the team will be notified. So we have the team members, okay? And these team members include developers, now, developers are going to be informed. Okay, so we have members of the team who will be informed. And who are these team members? Developers, DevOps. Now, so team members will be informed. Can you see that? So this is how the DevOps process takes place. Now, with DevOps, this entire process is automated such that in 1 hour, this entire process can run. In 5 hours, this entire process can run. This is DevOps end-to-end automation. And that's why companies are craving for individuals who have expertise when it comes to DevOps. And again, the application that you see here is what we call monolithic application. Nowadays, we have a lot of applications that are deployed, okay, using, okay, in the place of Ansible, we can use Docker and Kubernetes. Docker and Kubernetes. This will be common for microservices, and we are going to be seeing all of that. Okay, so if you are deploying a microservice application, we'll have Docker and Kubernetes here. So please take note, it's important. So this is the DevOps end-to-end automation. This is what DevOps is all about. With DevOps, you know, speed is deployed to production. Okay, and again, what are some of the things to also take note of? So today, we have looked at class, this is DevOps e-degree master program, 100% job, okay, guaranteed DevOps and cloud training. It will last for 220 hours. Okay, 19 weeks beginning from, now our next class is going to be, let me check the date. Can you see the mouse? Okay. Where is it connecting internet from now? Yes. I need more credit in that orange. Can you guys hear me? Can you
Yes,
hear me?
Prof, I can hear you.
Okay. Sorry for that. Okay. Let me share my screen again. Are you seeing? Okay. Okay, so we are talking about the DevOps e-degree masterclass, which is 100% job guarantee, DevOps and cloud training. Okay, study DevOps with Linux and cloud services, which is AWS, Azure, and GCP. Now, this is 19 weeks, beginning from our next class is going to be on Thursday next week. And can you confirm the date for Thursday, please? What's supposed to be that Thursday date? Oh, can you guys confirm Thursday?
19th of
Okay, so
October.
it's going to be running from 19th of October 2023 to February 28th, 2024. So please take note. That is how the program is going to run. And once we are done with that, we are going to be having 7 weeks of interview preparation and job assistance. This 7 week is boot camp. We are going to have what we call boot camp session. And again, weekly, we have 9 hours of lectures per week. 9 hours of lectures per week. Okay. And most of the time, we'll be having 6 hours of live lectures and 3 hours of recorded video. So please take note. Very important. Let me make sure. So we have understood the DevOps life cycle. Now, there's this question that we are always asked: the output of this course. What are you going? Which are the jobs you can do when you finish this program? You can work as a DevOps engineer, cloud engineer, infrastructure engineer, site reliability engineer, platform engineer, or you can work even as a Kubernetes engineer. So this is very important. I think we have some commonly asked questions. Let me go to that. Commonly asked questions in our GitHub repository. Commonly asked questions. Yeah. Commonly asked question. Admin, can you share the commonly asked? Okay, let me see something. If you take us directly there. Okay, so here we have some commonly asked question. To take note of it, let's go through the commonly asked questions. For example, now these are commonly asked questions or frequently asked questions. Okay, for example, our contacts. How can you contact us? Here's the website, or you can click on this WhatsApp link. It will take you straight to our WhatsApp. You're able to write somebody directly. Okay, and we have our link for email and for fee payment. Now, here is our contacts, the telephone numbers you can use to contact us. The next question engineers have always asked us is, Prof, who can study the landmark DevOps e-degree program? Now, the basic answer is anyone who have graduated from high school and who is at least 18 years. So if you're a high school grad, you are eligible. Now, when is the next class starting? The next class, class 34, will run from October okay, 14th, but again, it's going to be October 19th, as I because our next class will be Thursday next week to February 28th. And here are the timetable. Now, Thursday, 7 to 10 p.m. Saturday is 8 a.m., please. Admin, please, can you correct this time? And correct this time and the date, please. Now,
Yes.
I don't have an IT background. Can I still do this course and succeed? The answer is yes. We can take you from zero IT background to become a highly skilled and professional IT and DevOps engineer. As a matter of fact, over 95% of our graduates working today had no prior IT background before joining. What is the average salary of landmark trained DevOps engineers? The average salary, as you can see here, now the average salary is about $150,000 a year for a single job, and the highest paid landmark engineers are making over $700,000 a year. Now, not better, you can start making millions of dollars via our coaching program that helps engineers start their own IT companies. Okay, which kind of jobs can I do after completing the landmark DevOps Master Program? You can work as a DevOps engineer, DevSecOps engineer, cloud engineer, and AWS cloud engineer, platform infrastructure, Kubernetes, technical project manager, Scrum Master, build and release, or site reliability engineer. Now, one of our testifiers today got a job as a vice president for application development in their company. Now, how much is the fee, and can I pay an installment? The fee is $3,600 and can be paid in minimum installment of $700 per month, with $800 for the first month. You can also pay the complete fee upfront, which is recommended. Please type your name and class as payment reference, and send us screenshot to this number through WhatsApp after each payment. Fee payment for Cameroonian students. You can use MTN Momo. Here's the MTN Momo that you can use. MTN Momo numbers, either the first one or the second, if you are paying from Cameroon. You are paying from Nigeria, what can you use? Fee payment for Nigerian student. You can pay via Access Bank. The account number, that is it, account name Landmark Technologies Nigeria Limited. The fee is 2.5 million naira, and you can pay 500,000 naira per month. How can I pay my fee? You can pay your fee using Interact for those in Canada. You can use Zelle if you're in the US, or Cash App for those in the US. There's some folks in the UK also use Cash App. This is a payment email to use for all payment. For payment through PayPal, request an invoice, please. Always ask for an invoice, we'll send it to you. And this is a class schedule. What is the duration of the course? 4 months plus free bootcamp. Which kind of computer will I need for this course? A computer with at least 8 gig of RAM, 256 gig of hard drive, and 14-inch. That is the recommendation. Now, what other bonuses or help does this course come with? What comes in the combo? Now, the first thing that comes is a bootcamp, which includes resume preparation, LinkedIn profiling, interview reviews. We have both academic and work references, daily interview sessions, 100% job-oriented. And the most important thing is that the grace of God is at work in Landmark Technologies. Take note about that. Good news. Landmark 100% job-oriented DevOps e-degree master program with AWS, Linux, and Kubernetes have trained and graduated engineers from all kinds of backgrounds, including university professors, pharmacists, CPA, ACCA, CFA, lawyers, accountants, bankers, entrepreneurs, nurses, RN, CNAs, drivers, scrum masters, factory workers, PSW, personal support worker, disability support workers, students, etc. So please take note. These are commonly asked questions. So it's very important to take note of that. Now, that said, I'm going to give us some few minutes break. And when we come back from the break, we are going to start with the graduation proper, okay? And in that graduation proper, please, all our graduates, make sure that you're on video, and all our testifiers, make sure that you're on video, and class admin, get the validator ready once we come back. Okay, so we are going to have 10 minutes break, so we'll continue at exactly 12:55 p.m. please. So at 5 minutes to 1 p.m. So let's have 10 minutes break.